Okay, so this question reads, in the figure below, a boy is dragging a box of mass 8 kilograms attached to a string at an angle of 60 degrees. The box is moving horizontally with an acceleration of 2.0 meters per second squared. If the frictional force is 12 newtons, calculate one, the applied force, two, the normal force of the horizontal of the horizontal surface on the box, three, the coefficient of frictional force, and four, the net force moving the box. The net force moving the box. So first things first, to say we're supposed to draw a free body diagram when you've been given such a question. So I'll just draw a very small free body diagram because I'm going to put it here like that. Then you have your box. You have your box as such. Then there's a force that is being applied here at an angle of 60 degrees. Now, if there's that box like that, what does that mean? That means we can now continue with the forces that are acting on this particular object. So there will be the weight of the object acting down. There will be the normal force pointing in that direction. Then on the applied force, there will be the x component since it's being applied at an angle. Then there'll also be a y component there. Then there's friction, which is acting in the opposite direction of motion, like that. So those are the forces that are acting on this particular object, like that. So I have my applied force F here. Then this angle is 60. That means this one will be F cos 60 degrees since it's adjacent to the theta. This one will be F sine 60 degrees. This will be the normal force like that. Then this will be the frictional force. Then this will be the weight W of the object. Then they've told us to say the acceleration of the object is 2.0 meters per second squared, like this. Okay, so this is what we have. We have already resolved our forces. What are we supposed to remember? Friction, Newton's second law of motion, but also vertical equilibrium. I'm explaining to you about vertical equilibrium in the previous question. They're asking us about it in this particular question. So first things first, they want us to calculate the applied force F. They want us to calculate the applied force F. If you look at the applied force, it is uh, in two different axes. But let's use the horizontal axis in order for us to calculate it. So we're going to say summation of forces in the x-axis will be equal to mass multiplied by acceleration. This is part one. What forces do we have in the x? We have this one, which is acting in the direction of motion, therefore being a positive force, and the friction, which is acting which is acting the opposite direction of motion, which makes it a negative force. So I'm going to say F cos 60, my F cos 60 minus friction. Did they give us the magnitude of friction? Okay, they've given us the friction to say it's equal to 12. This will be equal to mass multiplied by acceleration. What is the mass? The mass is 8 kilograms multiplied by the acceleration, which is equal to 2. Okay, so my F cos 60 degrees minus 12 will be equal to 8 multiplied by 2. This is giving me 16, like this. This is giving me 16. So cos 60 is 0.5. Therefore, I'm going to have 0.5 F. F is the applied force being equal to 16 plus 12. Divide both sides by 0.5, even that side by 0.5. The 0.5 will cancel out from here. That means my applied force will be equal to 16 plus 12, which is giving me 28 divided by half. 16 plus 12, which is 28 divided by 0.5. This is giving me 56. So the applied force is 56 newtons. The applied force is 56 newtons. Okay. Part two is saying we should calculate the normal force. We should calculate the normal force. And we're going to use the same approach that I'm from explaining to you to say there is no acceleration in the y-axis. Therefore, we're going to say summation of forces in the y-axis will be equal to 0. What forces do we have? We have two forces that are pointing up in the positive direction of the x-axis, which is the F sine 60, the horizontal, the vertical components of the vertical component of the applied force, and the normal force. Then there's the negative force, which is the weight itself, which is pointing towards the negative y direction. So I'm going to say my normal force Fn plus F sine 60 minus weight W. This should be equal to 0. Okay, my normal force Fn plus F, we've already calculated the applied force to say it's 56. So 56 sine 60 minus the weight of the object. What is the weight? The weight is equal to mass multiplied by gravity. So this will be equal to 8 kilograms multiplied by 9.8 like that. This should be equal to 0. My normal force, Fn, plus, what is the value of 56 sine 60? What is the value of 56 sine 60?
48.5.
Okay, so plus 48.5 minus 8 multiplied by 9.8. Okay, 78.4. This will be equal to 0. Okay, 48.5 minus 78.4. 48.5 minus 78.4.
Is 29.9.
Okay, so we're going to have a negative 29.9 being equal to 0. Then I'll just take this guy and take it to the other side of our equation. That means my normal force is equal to 29.9 newtons. My normal force is equal to 29.9 newtons. As simple as that. Let's go to part 3. Part 3 is saying we should calculate the coefficient of friction. We should calculate the coefficient of friction. And since we've calculated the normal force already, we know to say friction is equal to the coefficient of friction multiplied by the normal force. They've already given us the value of friction to say it's equal to 12. This will be equal to the coefficient of friction multiplied by the normal force, which is 29.9. Then we'll divide both sides by 29.9, even that side by 29.9. That means my coefficient of friction will be equal to 12 divided by 29.9, which is giving me a 0.4. So my coefficient of friction is equal to 0.40. Then we go to the last part, which is asking us about the net force that is moving the box. The net force that is moving the box. So the box is moving in the horizontal axis. And what forces do we have in the horizontal axis? We have F cos 60 and the frictional force. So how can you calculate the net force that is moving the box? You can use two different ways. It's either you can use F net being equal to mass multiplied by acceleration. Since you already know the acceleration and you already know the mass, this will be the force that will be causing the object to move. Or if not, you're going to say the positive force, which is moving the object, which is the F cos 60, F cos 60 degrees minus the frictional force. This is going to give you F net. As simple as that. So use either of these and tell me the answers that you're getting. You can use either of those until give me the answer that you are getting. You already know the mass to say it's 8. We already know the acceleration to say it's 12. We already have the applied force to say it's 56. So you say 56 cos 60 minus the friction, which is 12. So each method that you can use, what answer are we getting? Anyone? What answer are you getting? Anyone? The value of 8 multiplied by 2.
That is 16.
So the net force that is moving this object, or that is accelerating the object, is equal to 16 newtons. That is what our friend has found. I don't know about the others, but if you're finding the same answer, then that means we are cool. Because even if you use this one, we said cos 60 is equal to half, it's 0.5. So 56 multiplied by 0.5, you're going to get 28 here. Then 28 there minus the friction, which is 12. This is still going to give you 16. It's the same thing. Even here, you just say 8 multiplied by 2. This is going to give you 16 newtons. So that is it, the net force in this particular case. And that marks the end of this set of questions. So before I end, I just wanted to remind those people who are not registered with us to say, if you're struggling with anything, let's say it's tutorial sheets or past paper questions, once you register, you go to your folder here, which is the January 2026. Press there. You're going to find the tutorial sheets that you're looking for here, from tutorial sheet 1 up to tutorial sheet 6, including the assignments. Everything has been solved. Nothing has been left out. All the tutorial sheets have been solved. Today we just concluded with tutorial sheet 7. That means it's also going to be added here. The same applies when it comes to past papers. You just go to the folder for past papers. You're going to find them. Our goal is simplifying the work for the students uh, in the best way possible so that it's easier to understand for you guys. Whether you are preparing for your test, you're preparing for a quiz, you're preparing for a presentation, we want to make sure you are getting the basic concepts from the simplest concepts before you start discussing the hard things, because you just build on from there. That's how we understand the physics. So if you're not registered, remember to register with us using the the procedure that has always been shared, and let's excel together in your academics.